Assalamualaikum warahmatullahi wabarakatuh. First of all, I want to introduce myself and my lab partner. My name is Muhammad Umar Aziz bin Abu Bakar, while my lab partner is Nur Sadiah binti Ismail. Recently, my lab partner and I has conducted an experiment, and the end we conducted the experiment was to study the way and how to prepare a ceramic material at two different temperatures, mainly at 1000 degrees Celsius and 1200 degrees Celsius, and identify the physical properties between the two ceramic materials such as density, hardness, volume shrinkage, and mass loss. Next, the experiment that we used in the experiment were weighing balance, Boltzmann machine, crucible alumina, pressing machine, box furnace, digital vernier caliper, and Vickers micro hardness testing machine. Okay, let's move on to procedure of the experiment. Firstly, the sample were weighed using weighing balance with 5 grams of clay, 2.5 grams of feldspar, 5 grams of quartz, and 0.1 gram of PVA. Then the powder were put into a container to be mixed. After that, the container was shook using Boltzmann machine to make sure the powder were mixed thoroughly in the container. The powder then pressed with pressure around 5 tons and made into a pellet form using hydraulic pressure machine. The pellet was put on box furnace and seated at two different temperatures, about 1000 degrees Celsius and 1002 degrees Celsius for 24 hours, followed by heating and cooling rate at 5 degrees Celsius per minute and 1 degree Celsius per minute. Finally, the diameter and thickness of the sample were measured using vernier caliper and the hardness by Vickers micro hardness testing machine. I will pass the baton to Sadia for explaining the result of the experiment.
So I am Sadia. I will explain about the result and discussion of this experiment. So the table 3 will shows the overall result for the physical properties of the ceramics. So firstly, the percentage of the mass loss having the increasing of the values, increasing of the percentage from the 7.68% to the 13.17% for the ceramic at the 1000 degrees Celsius and the 1200 degrees Celsius respectively. So this is due to the firing process at the sintering temperature, which a sample is experience the shrinkage in size due to reducing of porosity compared to the initial sample before the sintering. So I will show the comparisons of the ceramics of the low and high porosity. So for the low porosity, it shows that the ceramic in the compact shapes, whereas there's lower pores in the ceramics compared to the high porosity, which has a higher pores between the atoms, and it will shows in the orthorhombic bakings there's only 26 porosity compared to the cubic bakings. So the porosity will affect the mass loss and the others physical properties in this experiment. The percentage of volume shrinkage. So in this table, it shows the increasing in the volume of percentage of volume shrinkage from the 4.32 at the 1000 degrees Celsius to the 22.83% at the 1200 degrees Celsius. So the sintering process of a high thermal energy may lead to particles to join together and simultaneously reduce the volume of pores between them. So the percentage of a volume shrinkage of the pore between the atom and ion may increase due to decreasing of the volume of pores and also pores of the surface area. So the density of a ceramic having the percentage which is 3.51% and the negative 12.52% for the temperature 1000 and 1200 degrees Celsius respectively. Measure the density of a ceramic, which are the conventional method of the using the formula of the V equals to mass volume over mass, and the Archimedes principle method by using the methodology of a density measurement instrument. So the measuring density by Archimedes principle was more accurate because the magnitude of a buoyancy force in the fluids, which is equal to the weight of the fluids displaced by the ceramic. So the buoyancy force on the body floating in the liquid is equal in the magnitude of the weight of the floating object or ceramic is in opposite direction. So the object either rising or sinking. But in the conventional, it can also be used because it is easy to be calculated and without using any instruments. So next I will show the video of the how we want to calculate the
for the measurement of density of a sample by the Archimedes principle. And this is a very simple setup but very sophisticated here. Here is a stand. The stand is containing the beaker with water, where the sample is immersed to take the weight in water. And here is a hanging weight container where this hanging container helps to take the weight of the material or sample in air. And please make sure that during the measurement of weight, the bubble should not be in the liquid, and after placing the sample here, the bubble should not be on the top of the sample. So the bubble is an important factor here, and bubble should be completely removed from this setup. Now we are going to show how to take the weight of sample in air and weight of sample in water, that means in immersed condition. Please make sure that before taking the weight of the sample, the balance should be in tear condition, that means it should show zero weight. Now here I am taking the sample which is for the measurement of this sample in air. Just slightly open this upper door, and please make sure that this weight, this 00 should be maintained here. I am taking this sample here for the measurement of sample in here. Please the sample more or less should be in the center of this container. Just open that upper door, and when the weight should be taken, please make sure that the digits should be constant at least for 10 to 15 seconds, and note this data as the weight of sample in air.
Since a volume of pores and the pores surface area may affect the hardness of the ceramic. So the material hardness was determined by measuring the size of the indentations made by the sharp diamond pressed strongly on the ceramic specimen. So in this experiment, it will show the increasing in hardness reading which is 75.37 to 800.33 megapascal for the temperature 1000 degrees Celsius and the 1200 degrees Celsius respectively. So the ceramic of a sintering 1200 was more harder and have a high density compared to the ceramic of a sintering on the 1000 degrees Celsius. Hence, a porosity of the ceramics is much smaller and compact after the sintering of a 1200 degrees Celsius. So the ceramic have a larger density because the high in the percentage of mass loss and the volume shrinkage, which sample tend to be more smaller but compact in shapes. So in the conclusions, the ceramic that has a sinter at 1200 degrees Celsius has a higher hardness and density compared to 1000 degrees Celsius ceramic because it has a higher mass loss and volume shrinkage.